Today, let's talk about the basics of JNI, also known as the Java Native Interface. JNI is a framework that allows Java code to call native functions written in C or C++, and it also lets native code call back into Java. This is extremely useful when you need performance optimization, access to low-level system apps, or when you want to reuse existing native libraries. To understand JNI, we'll go step by step. First, in Java you declare a method using the keyword native. Unlike normal Java methods, this one has no Java implementation. Instead, you will load a shared library that contains the native code. For example, you can call system.loadLibrary and give it the name of your compiled native library. Once you declare the native method in Java, you generate a C header file. This is usually done by compiling your Java class and using the Javig tool with the -h option. The generated header file contains a method signature that matches your Java native method. Next, you implement the method in C or C++. The function name must follow a specific convention, which is Java_class_name_method name. Inside this function, you can write normal C code. For example, printing hello from C to the console after writing the C implementation. You compile it into a shared library. On Linux and Mac, this becomes a file ending with .so, while on Windows it becomes ADLL. When your Java program runs and calls the native method, the JVM links to this shared library and executes your C code. Now let's cover some important JNI concepts. Every JNI function receives a pointer called JNIenv. This gives you access to all the JNI functions, such as finding classes, creating new objects, and working with arrays or strings. Java objects are represented with special JNI types. For example, a Java int is represented as jint, a long as jlong, a string as jstring, and a regular object as jobject. JNI also defines rules for method naming. If your Java class is in a package, the generated native function name includes the package and class names separated by underscores. This ensures that the JVM can correctly match the Java method to the native implementation. When it comes to data exchange, JNI provides functions to create and manipulate Java strings and arrays. For example, you can create a new string in C and return it to Java. You can also access an array, modify its elements, and then release it back to the JVM. Before we wrap up, let's talk about best practices. First, keep JNI calls minimal because crossing the boundary between Java and C is expensive. Second, always manage memory carefully. For example, if you get access to an array or string from Java, remember to release it when you're done. Third, make sure your code is thread safe since JNI functions are not automatically reentrant. And finally, be aware that a bug in your native code can crash the entire JVM. That's a quick overview of JNI basics. With this knowledge, you can now start experimenting with native methods, exchanging data between Java and C, and building more advanced integrations.